Welcome to Teach Me to Program C++, Microsonic Development's first lesson on functions. Basically, I assume that you can understand the code that is on the screen right now, or at least for the most part. I'm going to go through it again, but as we go. But basically, you understand what is really going on here. So where we'll start is looking at this main method that we've already got. It's a little bit cluttered, and it's not too bad, I guess, but imagine if you had several methods or several computational events that were even just this short 3 lines of code. It can make this main method very messy very quickly, very, very difficult to debug. So, in using functions, we want to maintain readability and maintainability. Readability for both hobbyists and professionals. You want people to be able to read your code and understand what you're writing. Furthermore, maintainability, because you don't want to spend hours and hours debugging your code. You want to consolidate your code to a single method and quickly fix the error and be done, or add functionality without breaking things. So these are really big reasons, among others, that we are going to learn to use functions. So we're going to start by totally removing this entire method. It's garbage. It's messy. If we continue to program like this, we're not going to get very far. So first, being as C++ is a type-specific language, we want to convert that print hello statement, although probably unnecessary, but to stress the point of methods, we're going to wrap the print hello statement that we had below into its own method. So since we're only sending something to cout, there's no real reason to return. We have nothing to return, in fact. So there is a type for functions that don't return anything, and that's called void. It's just a void function. It does not return anything. No value. Well, so if you set something equal to it, you might get a compiler error. There's nothing to grab. So we're going to call it print hello. And there's our first function stub. A function stub is basically such that we can go here and type the method, and now the program won't crash. It can find a definition for the function, and it works appropriately. In this case, it doesn't do anything. So our function stub function stubs for void are very simple. You just need the open and close braces. So what we're going to do is we're just going to send hello, the word, directly to cout. And that's that function. That is a whole function right there. Notice that there is no return statement. If you recall earlier, in my main function I had a return 0 at the bottom. It is unnecessary in a void method if you're just returning at the end. Returning at the end is unnecessary because it automatically returns at the end once it hits the bottom. However, it is not wrong to explicitly return. Just don't do this, because that's incorrect for a void. You're not returning a value, just return. Or if you want to return before the cout method, you can put a return before here. And if you had a return here, technically the way this method is set up, nothing would happen. Hello would never be hit, because wherever the first place that hello is hit, or excuse me, return is hit, is where the function will drop out. So we'll remove that. Now we're going to go to our next method. We're going to abstract that random number thing we were doing earlier a little bit more. So it was an integer, so we're going to give it a type of int, and we're just going to call it random number. And here is our function stub. Notice how I had to return a value this time. Because there is an integer type, it requires that I return a value. But because we're just going to define this method right now, we're not going to stub it. So what we want to do first is declare some value. We'll call it ret for return, and we'll initialize it to 0. What this does is it gives us a value from the stack. It creates a local variable and sets its value to 0. This is not the value that will be returned based on the bounds we're about to set. So I'm going to create a quick for loop. I equals 0. I is less than 3. And then we're going to increment I. Think of this, for people still who are having trouble with the for loops, think of it like this in mathematical terms. 0 is inclusive, 3 is not. So in this for loop, we're going to declare another variable x, though this is unnecessary for what we will do. I'll explain in a moment. And we're going to take a rand. Then this gives us some random number, any random number that is seeded to. However, what we want to do is we want a random number between 1 and 100. So what we're going to do is use the modulus operator, which in C++ works exactly as it does in modular arithmetic. However, with the rand function, we can use it to bound the randomness. So we can say 100 upper bound for our, and then use the plus operator, and 1 for our lower bound. Before we do that, actually, though, a very simple way to make your rand function quote-unquote more random is to seed your rand. It's pretty much standard to do this. So you use srand. I'll put spaces because there's a few functions that we'll be calling here. We're going to static cast it, which, if you're familiar with C style casting, it's very similar. And then we're going to put time. Deals with pointers, so we'll discuss that in a later tutorial. So basically what happens is we seed the rand value to time to try and keep things more random. And we do this every iteration of the loop, as you see, because it's in the loop. We static cast it to an unsigned int. If this stayed as some standard integer value, it probably will be okay. The compiler may complain, but most likely you won't have any problems. But it is important to notice that an unsigned integer is different from a standard integer, as the standard int is signed. Signed and unsigned basically comes from a bitwise level. Notice that an unsigned integer does not have a signed bit, so that means it has an extra bit to express a positive number. The signed bit, an assigned integer, allows it to be negative. So you can express larger numbers in unsigned int, but they're only positive. You can express still fairly large numbers on a 32 or 64-bit system, but not as large as an unsigned int with a standard signed int. And that is because the signed int loses a bit to saying whether it's positive or negative. And another thing to notice, if you try to express a negative value in an unsigned integer, you will run into problems. It will probably be some very large positive number that you don't understand what you're getting. So keep that in mind. So now we have x set to some random value between 1 and 100. We don't know what it is, but we're going to set ret also equal to x. Great. So now we're going to return ret, and that is ultimately our function. Now it is important to notice that int x is unnecessary. So why did I put it? Basically, I want to show you how scoping works a little bit in a very local context. Notice that we declared this int within this for loop. So it is in the scope, we say, of the for loop. So by the time we exit the for loop, x no longer exists. As you see, we'll get an error here. Error identifier x is undefined. However, it's clearly defined within this scope right here. Right? We're using it, in fact. By the time we're out of there, ret has the value of the last x. So it is a usable variable within the context, within the scope of the for loop. And notice how we used ret in this. So basically what happened here is we declared a local variable ret in the scope of int random number. So this is good for the entire scope of the random number function, which is why the for loop can access this local variable. However, we did the same thing with x, but x is only good for the scope of the for loop. So by the time we're out of the for loop, it's no longer valid. It has been popped off the stack. It's memory that we don't manage, and we cannot help that. So you can think of this in this local context anyway, almost as a parent-child relationship. Think that as a parent, you have children living in your house. So they have access. This is your house. They have access to this, but you may not necessarily have access. They're not giving you anything. You're giving them a place to live here, but they're not able to give you anything. So the greater, the parent, quote unquote, of this whole method does not get anything back necessarily from the child method. So that's why we just simply set this local variable on the whole function scope rather than just trying to return x later. And that is because that's defined here, or it's declared here. If we were to throw this x up here by ret, everything would be fine. In fact, we could return x directly. But it's because of where we defined it in the scope. It's just an important concept to note when you're trying to access variables and you're getting errors and you can't figure out why. So as it stands, this program is it's ready to compile. However, it won't do anything. You see, this method here is the entry point to a program. Int main is where everything starts. So if nothing is declared here, nothing will happen. Furthermore, if a method is not called from here, it won't be called directly or indirectly. That is, we can call random number here, correct? And if random number actually calls print hello will still be called. But if random number as is, print hello would never be called if we were just to compile this program as is at this very moment. So what we're going to do then is actually write the main method. We want to declare some local variable to main, t, equal to random number. Now what this will do is this will give us a stack variable t, good for the entire method main, and it will execute the entire random number function. When the random number function has completed, we will get the value of ret, and ret will be stored here. And then all of this memory, the original ret, will be deleted. This will be a separate copy, t, of the value of ret. So now we have ret, and we're going to print hello. So at this point, if we were to compile the function, we would have a random value t stored in a variable, and on the function window we would actually see the word hello, and that's it, because we haven't printed or done anything with this variable. So let's do that. Random value, we'll call it t. Great. So we have the random value printed out, and we are ready to compile this program. Now you may be thinking, what about this type? I thought C++ was a type-specific language, and it's very important to return where valid. And that's true. However, due to the standard, C++ standard, returning from main is not necessary. However, it is probably most common to see this, as I had before. Although, again, like I said, main will return on its own. It's unnecessary. However, this is absolutely necessary in the random number function. You cannot have any other function with some type not return. So now we should have a function that prints hello, and on the next line says random value, and then whatever that random value happens to be. And since I'm on Windows, I'm going to do a little trick. I'm going to scope std for the namespace, although we're using namespace. This is another way to scope using the scope operator, which is 2 colons. And we're going to take the syn method, and we're just going to type .get. And what that will do for us on Windows is pause. Not out of error, but based on how I will be starting the program. And there we go. It says hello random value 51. Now we can try again to see that it's really a random value, 74. And that's really all there is to it. Now you can notice about this code that it's significantly more readable than it was before. If we had an issue to where we didn't want the value 74, we didn't want any value over 60. So we could say, okay, we're printing here at this statement. So t is what we're printing. It's getting its value from random number. We've consolidated our debugging to the function random number, and we can make the quick fix here.